Hello everyone. Good morning, good evening. Let us start discussing about the topic called Snowflake key concepts and architecture. Okay, let me pull up my screen. Hope you guys can see my screen. So coming to the Snowflake key concepts and architecture, before we understand much deeper about Snowflake, so this is the important chapter. So Snowflake is powered by an advanced data platform that is provided to you as a self-managed service. Snowflake data platform brings together data storage, processing, and analytic solutions that are faster, easier to use, and far more flexible than traditional offerings. So the data storage means bringing the data and storing into Snowflake data storage. How the data storage will happen, how the compression techniques Snowflake will use during the data transit and at stage, how it is going to take care, we can discuss in further chapters. But right now, we completely focus on the key concepts and architectures of Snowflake. So Snowflake combines a completely new SQL query engine with an innovative architecture that is natively designed for the cloud. So when the Snowflake started, the idea of the data warehousing on cloud, it's purely designed for the cloud. So it offers full enterprise analytic database functionality and unique features capabilities. So first thing is data platform as a self-managed service. So as a self-managed service means, like as I said, it's a SaaS, software as service. Like others, we have platform as service, right? So similarly, and infrastructure also as a service. So Snowflake is called as SaaS, software as a service. So here, there's no hardware for you to select, install, configure, or manage. There is no headache of the hardware installations by our own. Snowflake handles that part. Second thing is there's virtually no software for us to install and nothing to be managed by us. If any new versions comes, new features comes, Snowflake will handle that, pushing those services or features as part of the SaaS. Next is ongoing maintenance, management, upgrades, and tuning are handled by Snowflake itself. So this is why it's a self-managed service where Snowflake offers. So coming to the storage, like virtual computation, instances, and persistent data storage, Snowflake uses public cloud infrastructure to host these virtual compute instances. We'll talk about virtual compute instances in further uh, slides. So Snowflake manages software updates and infrastructure, so you don't have to. You can't install and run Snowflake locally or on private cloud infrastructures, whether on premises or hosted. This is all about data platform as a self-managed service. Now let's go on to the architecture. This is very important as part of the any cloud offerings. So we need to understand the architecture first. Snowflake architecture is a hybrid of traditional shared disk and shared nothing database architectures. We will explain that, right? Similar to shared disk architectures, Snowflake uses a central data repository for persisted data that is accessible from all compute nodes in the platform. So, but similar to shared nothing architecture, the Snowflake process queries using MPP. massive parallel processing clusters, where each node in this cluster stores a portion of the entire dataset locally. So this hybrid architecture, which is shown in the following diagram, if you see, so here the entire database storage. So let me, so this is the entire database storage, which we call it as database layer. And the second one, which is nothing but virtual warehouses, which we call it as compute layer. And the third one, which is this, which is actually the brain of the system, which we call it as cloud services. Okay. So this is the simple architecture which we can easily understand. So let us talk about one by one layer. Like we have three layers as part of the key layers are database storage, which stores the persistent data. Compute layer will help us to run or processing the queries. Third layer, which is the topmost layer, which is called cloud services layer. Okay, so coming to the database storage layer. So Snowflake supports first, right, what kind of data which we can process to database storage is like it's a three types of data it supports. One is structured data, such as rows and columns in a table. It's like RDBMS stores, right? So that regular Oracle database or other databases, which we heard also many times. Second one is semi-structured data, such as JSON file or an XML file, which has a flexible schemas, not like structured data will have, right? So semi-structured data will have flexible schemas. And third one is unstructured data, such as a document or image or audio file, has no inherent schema. So Snowflake supports these three types of data. Now coming to the how it supports these three types of data is like storing them in the form of tables. Okay, so those tables Snowflake categorized into three types. Snowflake tables, will deep dive into that, and Apache Iceberg tables will deep dive more, and hybrid tables. So Snowflake tables, when data is loaded into Snowflake table, Snowflake reorganizes the data into its internally optimized compressed columnar format. So this is the notable point here. If you see, internally optimized compressed columnar format. So Snowflake stores this optimized data in cloud storage. So Snowflake tables are ideal for data warehouses. So like permanent tables, we'll deep dive in more into when we are explaining about Snowflake tables. Snowflake manages all aspects of how this data is stored, including the organization, file size, structure compression, metadata, and statistics. All data in Snowflake tables is automatically divided into micropartitions, which are contiguous units of storage. Micropartitions improve efficiency and provide other benefits. We will discuss like more when we are talking about the how the data is compressed, what are the compression techniques that we have, and what is micropartition inside in Snowflake, how the micropartitions will help us to prune the data while fetching it. So we'll talk more about during that. Okay, so now let us move on to the Apache Iceberg tables. Apache Iceberg tables for Snowflake combine the performance and query semantics of table or typical Snowflake tables with external cloud storage that you manage. They're ideal for existing data lakes and data lake houses. So that you can't or choose not to store in Snowflake. Okay. So Iceberg tables store their data and metadata files in an external cloud storage location. For example, Amazon S3, Google Cloud Storage, or Microsoft Azure Storage. Coming to the hybrid tables. So as the first one, we talk about Snowflake tables. So they are purely for data warehouses, and they can only enforce the not null constraint. They cannot enforce, or you, even though you create it as a primary key, defined it at that Snowflake type tables, so it cannot enforce it. So that's where, as the Snowflake introduced, hybrid tables are optimized for low latency and high throughput by using index-based random reads and writes. Hybrid table supports row locking and enforce unique and referential integrity constraints. That is what I told. For the first Snowflake tables, that is not there. So you cannot enforce these referential integrity constraints and unique constraints rather than not null constraint. So for OLTP kind of structures, hybrid tables will be useful. Okay. This is all about your database layer in the architecture, which is the first layer where we store the persisted data. Second thing is compute. Second layer is compute. So that when we see the compute, so let me go back and show it here. So the compute, if you see virtual warehouses, we can see it here. So the compute layer will be is talks about more of a virtual warehouse, which is a cluster of compute resources in Snowflake. Virtual warehouses process SQL statements and using Snowpark run code in languages such as Java, Python, and Scala. With Snowpark Connect for Spark, you can also run Apache Spark workloads on virtual warehouses. While creating the virtual warehouses, I will explain more and more. So until then, just keep an eye that, okay, keep a note that virtual warehouse is a cluster of compute resources to process the SQL statements and other Spark related and Java and other code. We will use virtual warehouses. Each virtual warehouse is independent compute cluster that doesn't share compute resources with other virtual warehouses. That's what we discussed. Shared disk, but not like shared resources. So let me go back to this. So here, if you see shared disk and shared nothing database architectures, right? So heavy, massively parallel processing, MPP processing we will use as part of this compute layer. And each virtual warehouse is independent, is an independent compute cluster that doesn't share compute resources. As an example, I can describe here is, if we have ETL team, BI team, business intelligence team, and data science team, and AI team. So we can create 4 virtual warehouses. Each can be segregated and each cannot dependent on each other. And they can do their processing of the queries, not to queue the other loads, right? And the other one is other usage and helpful about this one is not only about queuing, right? We can have billing problems also. So which team is consuming more and which is, I mean, credits control should be taken care. So to identify that, you can use taggings for each virtual warehouse so that who has run how many credit, who has consumed how many credits, which can be useful as well. So the real-time scenario, when we can think of this, each virtual warehouse is an independent compute cluster that doesn't share compute resources, is that use case. So when you have multiple teams which are working, I mean, are responsible for data loads, business intelligence dashboards, data sciences, AI, and if you have any other teams, downstream applications, if you have, each can be having their own virtual warehouses and cannot dependent on each other, and which cannot even impact any others queries or any others performance on data fetching side. Okay, so that's all about virtual warehouses, which is nothing but a compute layer. The last layer, which is the cloud services layer, which is the brain of the system. The cloud service layer is a collection of services that coordinate activities across the Snowflake. So it is like, for example, if you see the security, authentication, and access control, and Snowflake Horizon Catalog, while you are accessing the infrastructure management with cloud platforms, metadata management, like as part of the partitions, while it is processing the data into partitions, micro partitions, it keeps the metadata management, like what is this total number of rows? Okay, how many nulls are there? How many, what is the minimum? What is the max? So these values are auto pre-calculated, and whenever you hover over the cursor on the table, it tells you all these things, and there is no cost for this. Okay, so that is what it metadata management will does us, and query parsing and optimization. Whenever a query comes, so the while I mean the while parsing, optimization techniques also will be used by Snowflake itself, and that is where this metadata will help. That is where the computation layer, cloud services layer will help us. Okay, so now this is all about your the cloud services layer, which is the brain of the system, and coming to the integrated features for our workloads. So these features, so instead of moving data to a different system so that different teams can complete specific operations and tasks, you can bring all of your workloads directly to their data with an integrated set of features like data engineering, analytics, AI, ML, and applications and collaborations. These are all supported by Snowflake itself. So when it comes to the data engineering, so if you see, Snowflake separates storage and compute, which simplifies some traditional challenges of data engineering, right? Such as infrastructure management, performance tuning. So Snowflake provides several ways to ingest data, including like copy into. So suppose if you have a data in cloud in files. So if you want to load, for example, from Azure Blob Storage or AWS S3 or from GCP storage, if you want to load those data in files to Snowflake table, so we can use copy into command for batch processing. And for example, if you wanted to make this copy into as like auto ingest without having any manual intervention, we can utilize Snowpipe. So the difference between this copy and even in Snowpipe also we will use the copy into command only, but we will have some orchestration enabled for Snowpipe between the cloud storages to Snowflake. So the moment file lands into the storages, cloud storages, automatically it ingests the data into table without having manual intervention. Coming to the third feature, which data engineering team might get help is Snowpipe stream. It loads row level data. If you see the first two commands copy into and Snowpipe, they are file level ingestion. So here if you see the Snowpipe streaming is loads row level data continuously with low latency using the Snowflake SDKs or REST APIs. Okay, and the fourth one, like OpenFlow connectors, ingest data from specific sources by using connectors built on Apache NiFi, such as Microsoft, SharePoint, and Google Drive. If you want to bring the data and ingest into Snowflake, so you can use this OpenFlow connectors. And last one is Snowflake connectors. They connect from external applications and systems and stream data into Snowflake. So we can further deep dive later in for next videos. So Snowflake also provides several ways to transform the data, including like dynamic tables, streams and tasks, Snowpark, DBT. It Snowflake provides these ways to transform our data. First thing is we ingested the data. Second thing is we are transforming. So Snowflake supported both the features which are needed for data engineering. Okay. And coming to the next one, analytics. So analytics like some aggregations, window functions, common table expressions, they're all will be there in Snowflake itself. So the entire data engineering functionality we were able to achieve here itself. So that's where bring your data and do all these data engineering stuff. And even we can use Cortex AI functions for text and image processing and with large language models from OpenAI, Anthropic, Meta, Mistral AI, and DeepSeek. We have a support like semantic views where they store semantic business concepts directly in the database to define business metrics and model business. So once we deep dive into each and everything, probably you can easily understand, but just keep an note that okay, Snowflake supports the data engineering from loading the data and transforming it, analyzing it, and even utilized for AI functions as well, and semantic views as well. So coming to the AI ML, so Snowflake has Snowflake Cortex, Snowflake ML, so which can help in terms of um, usage of that to perform AI and ML feature engineering, training, and inference your Snowflake data. So models can access your most up-to-date data in a secure environment. It it helps even applying the guardrails not to share the data, which it can store the vector form of data, and it supports the embeddings, it supports the eval models. So from a ingesting data to till AML and data science team, it can have all the features. And on top of it, like applications, like Streamlit is one of the open source Python library. It uses open source Python library to create and share custom web apps. Okay. Suppose if you want to create some an UI user interface for ML and data science, probably like suppose if you want to provide an UI to search, like for example, what is my current usage or what is my products count based on the product, what is my existing supply chain, how it performs, so how it is doing, all those things. If you want to provide it to a business user, you can create a Streamlit app which can help business users by using this AI ML chatbots, everything it can they can query. Even for example, if you want to convert a natural language to SQL, you can create and give it as. But Snowflake already have that inbuilt, so we don't need to create such kind of things. But natural language to SQL, it does it automatically. But apart from that, if you want to have such creating an agentic AI, all those models, if you want to create and give an UI for business users, so definitely you can use it Streamlit. And Snowpark container service, they can be used, deploy, manage, and scale containerized applications from directly inside the Snowflake. And these are all like which will be application collaborative things. And Snowflake includes support of the following kinds of collaboration, like you can secure data sharing, you can list your data into Snowflake marketplace, and data clean rooms. So these are the collaborative applications and the collaboration it can provide. So, and SnowGrid is Snowflake's cross-region, cross-cloud technology layer. With SnowGrid, you can achieve the connect a data ecosystem across different cloud regions and providers, and apply consistent security and governance policies, enable disaster recovery and business continuity capabilities. The last one, which is as part of the collaborations and all. So connecting to Snowflake, how we can connect to Snowflake? There are many ways. Snowsite is a web-based UI where you can connect. The second thing is Snowflake CLI, which is a command line interface where you can connect through that as well. And native APIs that it can support is Snowflake Python APIs and Snowflake REST APIs to create and manage Snowflake resources programmatically. Drivers like JDBC, ODBC to connect to other applications. And native connectors that you can use to develop applications for connecting to Snowflake. For example, Apache Kafka, Apache Spark. So native connectors are there. Third-party technologies that you can use to connect applications to Snowflake, for example, extract, transform, load tools such as Informatica, Matillion, BI tools such as ThoughtSpot. All these third-party technologies you can always connect to Snowflake and do operations like ETLs. If you do not want to use Snowflake as an ETL tool, probably you can bring in other ETL tools which are native and third-party technologies as well. Okay, this is all about the Snowflake key concepts and architecture. Hope you guys like it.